All right, so now assuming, now we can't make all these assumptions, but if you're getting onto 3F, it means that you've learned how to move backwards and forwards with transformations. Now it's applying. So they want you to sketch the graph of f of x equals to 2 over x minus 3 squared plus 4. State the equations of asymptotes and axis-intercepts. So this is just straight to the point. I want you to sketch that. Okay, now from year 11, most of you should be able to read this now. So let's test your skills. What is plus 4? What does plus 4 do? Can I please have, let's go with Luke. Good. So we know y transformation up 4, so you can say y plus 4. Okay, so there's a plus 4 there. Cool. What is the x minus 3 in this truncus function? Because it's something over something squared. So it's fractional with the square, so it's the truncus. What's the x minus 3 do? Let's go with Vibha. Very good. This is a translation of 3 to the right. So this is 3 right. So essentially, you know, it's like this. Okay. And then the hardest one. Dilation is usually the tricky one. So let's have a go with this one. What's 2? Translations are easier. Leo?
Dilation of factor 2 from the x-axis.
Very good. That is correct. It's a vertical stretch. It's a vertical stretch. If you want to know if it's a vertical or horizontal, anything to deal with the x. So at the moment, what am I squaring? It's the x minus 3. If I had a number in front of x right now, that's a dilation factor from the y. But because it's not, it's definitely dilation factor from the x-axis. So I know it's affecting my y. The only question is it 2 or is it half? And if you're not strong with it, that's why doing the mapping notation is the way to do. So exercise 3E, just double check. But if you're strong at it, then yes, the answer should be 2y. And how do you know? Here's how you would know. So you know that the original function was y equals x squared. You're mapping to now the new one, which is 2 over x minus 3 squared plus 4. And if you do what I just showed you for exercise 3E just now, you'll get that as your transformation. So you can see, here's your x dash minus 3. So if I map them together, if I match them together, then x dash minus 3 equals x, and that's why you can see x plus 3. That's how we got that. Okay? And then same thing with the y's. If you move everything across, you should get y dash minus 4 all over 2 is equal to 1 over x dash minus 3 squared. And then you match these two. So if you match those two, that's how we will get that 2y plus 4. So you can see y is equal to y dash minus 4 all over 2 times 2 to both sides to get rid of a fraction. Add 4 on both sides to get rid of minus 4. And that is how you guarantee that you know the transformation. But that relies on the fact that your 3E is good. Okay, so if you're 3E strong, after you do a couple of them, you should be able to do what we just did. Read the equation. And that's what the examiners want. They don't care about this. They do not give you marks for this. They don't care. They only care if you sketched it right. You get your 3 marks from axis intercepts and any asymptotes. Okay, so based on what we can see, moving to the right by 3, so I should expect a vertical asymptote. Make sure to use a ruler. I'm just doing it very lightly here, so hence it's not perfect. But make sure you use a ruler when you do it. Asymptote at x equals 3, label the equation. Don't leave it like that, and don't leave it with a 3 here. Actually write x equals 3 as your asymptote. You also have a horizontal asymptote. Does it move up? Yes, it does. It goes up by 4, so you can do it like this. Make sure to use a ruler. Label y equals 4. There is no reflection, so that means the shape should still be something like this. The only thing I'm missing, x and y intercepts. Okay, so in this exercise, especially for truncus functions, it's just revising what you learned from last year. How do you find x and y intercepts? Here we go. Y intercept is the easiest one to figure out first. How do you find y intercept again? You do what? To find y intercept. Let x equal 0. So sub x equals 0. Find y. So how do we do it? Here we go. Here's our original equation. Where is it again? It was f of x, and we're trying to find f of 0. 2 over 0 minus 3 all squared plus 4. Yep. Oh, whoops. It's not a truncus. I drew a rectangular hyperbole. Whoops, my bad. Thanks for correcting me, or I was tricking you and testing you. No, I actually just misread the question there. Yes, it's a truncus, so it should look like this. Oh, that means there's no x-intercepts. But I was looking for y-intercepts, so it should work. All right, cool. It's testing. So 2 over negative 3 squared is 9, plus 4. 9 times 4 is what? 36. 36 plus 2 is 38, so 38 on 9. Okay. And there we go. So we know this coordinate up here is 0, 38 on 9. Or you could say 4 and 2 ninths. So I've got my equations of asymptotes labeled. I've got my y-axis intercept labeled. State the range of each function. So state the range of this function. It should be y is an element of greater than 4. So you can say so far so good. Okay, so this, again, like I said, it heavily relies on the fact that you've learnt D and E well. I know I just taught E, but that's a revision of last year. That's how you apply it. So I'm going to stop the video there. You can have a go with the next one. I'll write the solutions up so you can have a look at it. But that's what you're doing for F, G, and H. F, G, and H is just a variety of different functions, but same skills. I is the only one that you then, it's a nice to know for function notation. Core, D and E. So if you're pressed for time, work on D and E. That is literally the core skill of chapter 3.